Okay, so this is video 3 for 3.2. This should wrap it up. The last thing we need to talk about is zeros of multiplicity. Right? So this says if C is a zero of multiplicity m, then the shape of the graph of P near C is as follows. Now, instead of using this terminology, I would like you to see it as a factor. Okay, so we're going to have x minus c as a factor. So this x-intercept is positive c, right? And then the multiplicity is going to be found on the exponent of that factor. So there's two cases, right? The first case is if m is odd, and the second is if m is even. So if m is odd, if the multiplicity is odd, so when we factor this polynomial, if the factor has an odd number on it, then what's going to happen is that the graph will cross the x-axis at C. Okay? Graph will cross at C. Right? The other case, if m is even, right, that's this case, you'll notice that the graph doesn't cross. It just comes down and touches or bounces, okay, either from the top or the bottom. So we'll say if m is even, the graph will touch at C. Right? So even, touch, odd, cross. So what I'd like to do is I'd like to look at this extra worksheet. These problems here on this handout, okay, all these other finding zeros, I'm going to replace those with this worksheet. So page 4, okay, under Files, 3.2, page 4, should look like this. Right, it's just a bunch of graphs here. And what we're going to do is we're going to write the factored form of these graphs, right, using our knowledge about int behavior, zeros, and their multiplicities, right? So I'm going to do the first two and show you how to complete them, and then I think you should probably pause the video and see if you can do 3 through 6, and then we'll check it together, okay? You can unpause it and you can check to see whether you've got it right. So the first thing I'd like to do is I'd like to mark the x-intercepts. Right? So we have x-intercept at -3, an x-intercept at 0, and an x-intercept at 5. But instead of calling them x-intercepts, I'm going to call them zeros. Right? So I have zeros, -3, 0, and 5. Now, on the main line, I'm going to write these zeros as factors. Okay, so if -3 is a 0, x minus -3 is the factor, so minus a -3 becomes x plus 3. If 0 is a 0, x minus 0 is the factor, but we're just going to write x out in front. We don't usually write x minus 0 as a factor. And then if 5 is a 0, x minus 5 is the factor. Okay, now I'm going to fill out the multiplicities, right? So at -3, this graph is crossing. At 0, it's crossing. And at 5, it's touching, right? So if it crosses, then the multiplicity is odd, and if it touches, the multiplicity is even. Now I'm just going to use the smallest odd number, which is 1, but technically you could put a 3, 5, 57 on here. It doesn't matter, right? So it's crossing at -3, so I'm going to put an odd multiplicity. It's crossing at 0, so I'm going to put an odd multiplicity. And then it's touching at 5, so I'm going to put the smallest even multiplicity, which is 2. Now what's cool here is if you were to add up the multiplicities, 1 plus 1 plus 2, that would give you the degree. So I know this polynomial is degree 4. So that's even, right? So we know that both ends should be the same. Now, we don't have any negative x's, so both ends are up. Okay, so the degree matches the end behavior. So number 2, let's do the same thing. I'm going to mark the x-intercepts. -2, 0, 3. Okay, I'm going to write them down. I know this function has zeros, -2, 0, and 3. And then I'm going to take those zeros, I'm going to write them as factors. If -2 is a 0, x plus 2 is the factor. If 0 is a 0, we have x as a factor. And if 3 is a 0, x minus 3 is the factor. Now let's do the multiplicities. At -2, the graph is crossing. At 0, the graph is touching. At 3, the graph is touching. Right? So cross means it's odd. Touching means it's even. So at the x plus 2, I'm going to put an odd multiplicity. At 0, I'm going to put an even multiplicity. So I'm going to put a square there on the x. And at 4, I'm going to put an even multiplicity. So if I were to, again, add up these multiplicities, it should match the degree. And the degree should match the end behavior. So 2 plus 1 plus 2 means this is degree 5. So our end behavior should be opposite, right? And it's positive and it's going up. Okay, everything is lining up. So go ahead, pause the video and see if you can complete 3 through 6 on your own. I'm going to go ahead and work these now. All right, so we have zeros, -4, 0, 2. So I have factors x plus 4, x minus 2. This graph here is touch. At 0, it's crossing, and at 2, it's crossing. So I have 1 even multiplicity and 2 odds, which means this degree is degree 4. So both ends are up, and that matches an even polynomial behavior. X-intercepts, -5, -2, 1, and 4. So I have zeros, -5, -2, 1, and 4. So if -5 is a 0, x plus 5 is the factor. -2 is a 0, x plus 2 is the factor. 1 is a 0, x minus 1 is the factor. 4 is a 0, x minus 4 is the factor. Alright, so this is touching, crossing, crossing, touching. So touch is even, crossing is odd, crossing is odd, touching is even. So what degree is this? 3, 4, 5, 6, degree 6, which is even, which matches my end behavior being the same. Alright, on number 5 here, -3, -2, 0, 3, 6. So I'm just going to skip to the factors. Factors x plus 3, x plus 2, x minus 3, and x minus 6. Touch, cross, cross, touch, cross. Okay. So touch is even. Even on the -3, odd on the -2, odd on the x, even on the 3, odd on the 6. So what degree is this? 3, 4, 5, 6, 7. Degree 7. So the end behavior should be opposite. Now this one's a little different because this end behavior is going down. Right? If I were to connect these two arrows, And so that means it should have a negative leading coefficient. So how do we do that? Okay, very simply, we just put a minus out in front. That's going to negate the first term. Okay. All right, so then the last one, let's go ahead and mark the intercepts. The intercepts are the same thing as the zeros. If negative 4 is a 0, x plus 4 is the factor. If negative 1 is a 0, x plus 1 is the factor. And if 2 is a 0, x minus 2 is the factor. Okay, so this is touching. This is crossing. This is touching. So touching is even. Crossing is odd. Touching is even. So this is degree 5, which means the end behavior should be opposite. It's going up, so all my x's should be positive. Right? So if you can understand, even versus odd multiplicities, touching versus crossing, end behavior, okay, and then most importantly, the difference between a 0 and a factor, I think you will be good to go for 3.2. If you have any questions, please do not hesitate to contact me.